Hey everybody, and thanks for tuning back in to my Opnsense at Home YouTube series. I apologize that it's been a little while since we got our last video out, and since this is the first video of the year, Happy New Year. Now, we're going to take a bit of a step backwards today, because since my first video on DNS and DHCP in Opnsense, Opnsense has been updated to include some new ways to utilize DNSMasq and DHCP, and actually the method that we used before using Unbound, which is still fine, but specifically the DHCP version we were using, ISC DHCP, is being deprecated. So it's probably a good time to take a look at what new methods of DHCP are available in Opnsense. Another thing I want to do today is take a second to talk about what DHCP and what DNS are for those who might not be familiar. So let's start there. DHCP, or Dynamic Host Control Protocol, hands out the IP addresses inside of your network to your devices. Your devices will be identified using their unique MAC addresses, which are unique to every individual device. DHCP will give those devices an IP address, also known as a lease. This is a temporary assignment of an IP address specific to your network that will have an expiration date. And at that point, it can negotiate with the DHCP server to either renew that lease or get another lease of an IP address within your network. If you don't want IP addresses within your network to rotate, you can assign them static IPs or make reservations, essentially saying that you want to reserve a specific IP address to a specific MAC address, so that when that device comes on the network, it will retrieve that IP address from the server every time it connects. DHCP is also responsible for handing out a few other details to systems on your network that are going to be relevant for today, so we're going to talk about those briefly. First is going to be the subnet mask. For most of you, this is going to be set it and forget it, a subnet mask of 24. For almost every home network, that's more than enough. And if you need additionals, you can create additional subnets, again, in that /24 space. But a subnet mask is essentially an identifier to help create sub-networks. It's right in the name. If we change the subnet mask, we change the size of the network that you have, increasing or decreasing the total number of IPs available to your server. I plan on at some point making a video talking all about subnet masks and subnetting, because it is sort of a tricky subject for a lot of people who are getting used to it. But when you're just setting up a home network, if you really don't want to dive into the weeds of it, it's perfectly acceptable to stick with the default of /24 anytime that it's asking for what's called a CIDR notation. /24 is the same thing as 255.255.255.0. So if you see either of those two numbers, /24 or 255.255.255.0, associate that those are the same thing, and you'll cruise right through the rest of this. The next piece of information that DHCP hands out to your devices is the default gateway. This is basically saying anytime you need to leave this network and you don't know where to go, you come to me. You come to this IP address, usually your router, or in this case our Opnsense box, and this is what will route you to other networks. Whether that's the internet, whether that's other subnetworks, has to go through the router. And finally is the DNS servers. DHCP will hand out the IP address of where you're going to talk to get your DNS resolution. DNS, also known as the domain naming system, is just simply what translates IP addresses into domain names. So the DNS server on your network will be responsible for translating, for example, 8.8.8.8 into google.com. And it does this by checking its local DNS inventory, seeing what it knows the locations of, and if it doesn't know the location of whatever it is that you're trying to resolve, it will forward that query upstream. This is what allows us to create local internal DNS entries. We can have our own for example, .internal or .local or .lan domain inside of our network. And we can actually resolve using DNS the names of our devices on our network. Then, if we need to access something external, our DNS server forwards that request out. So fundamentally, things like ad blockers and Pi-hole will take a list of known ad or known bad URLs or domains and just not forward those requests, making it so that your devices just never find out where those domains are. There's a lot more to both DHCP and DNS, and there's a lot that you can do with them. But for the scope of today's video, that should be enough information to get us going. Again, for today, both the gateway and the DNS server are going to be the same thing. It's going to be the internal IP address of our firewall. However, if you wanted to set something up at home like Pi-hole, you would go into your DHCP and you would change the DNS server to the IP address of your Pi-hole server. So, what we have here is a brand new install of Opnsense. This is 26.1.2, so it's the February 2026 release. This should be the most current version, and from here we should be able to take a look at everything as far as the new DNS and DHCP options. Although, I'm not going to be touching on Unbound DNS today, other than showing how to migrate from the previous setup that I had talked about to the setup that we'll get to today. So going back to that video is still perfectly useful information outside of the ISC DHCPv4 stuff, which again, we will see some examples of today, how to migrate. But first, take a look at how things are configured. If we go to Interfaces, LAN, we can see that we have a default interface with a static IP, and that IP has been set to 192.168.1.1 by default. And as you'll remember before, we talked about that subnet mask being 24. So if we go to Services, you'll notice that we no longer have ISC DHCPv4. Now what we have is DNSMasq, DNS, and DHCP. If we go to General, we can see that it is enabled. And remember that if you're ever curious about what any of these entries do, you can click on the little orange eye, and we can see here, DNSMasq is enabled. And it is enabled on the LAN interface. By default, DHCP is actually configured for DNSMasq. If we wanted to disable DHCP, you would go into advanced mode, and we would scroll down to the DHCP settings, and this interface list here is actually not a list of interfaces that we want DHCP on, but actually a list of interfaces that we do not want DHCP on. In this case, we're going to be handing out DHCP on our LAN interface, and we shouldn't need to make any configuration changes. If you had a domain suffix that you wanted to use for your internal network, you could put it here. Or if you own a domain, you could put it here as well. Or if you want to use your domain in specific subnets that you're going to be handing out addresses from, you can do that from the leases section. This option, DHCP Register Firewall Rules, is basically just going to create firewall rules on our internal interfaces to allow devices to talk to DHCP. Other than making sure that we see that it is enabled, that no interfaces are disabled, and that the DNSMasq service is enabled, DHCP is running. So let's go and take a look at our DHCP ranges. In this case, we can see the interface, and if we expand the interface, here we can see the default range for both IPv4 and IPv6. If we wanted to edit this range, we could simply hit the edit icon. And we can expand this out to anything between, well, we can't use 1 because obviously that's our firewall. We could set it to anything from 2 to 254. The reason for that being that 255 is the maximum, but we always need to reserve the last address in a subnet. Now you'll see here subnet mask is actually set to automatic. The lease time is the number of seconds between the polls where devices will need to re-talk to the server to refresh their lease. Domain is where you can go in and set that domain on a per subnet or per DHCP range basis. For example, if we had a domain .local, but we wanted this to be our home DHCP range, we could actually say .home.local, and any device that gets an address from this range would have the DNS resolution of device name.home.local, and then we could leave just .local as the default for any other range. Again, there's not actually a reason to make a lot of changes here, and that's one of the big things that comes with DNSMasq is sort of the simplicity. The default configuration out of the box will get most people going. There's no reason to have to come in here and change the subnet mask or the interfaces. So if we want to look at some of the other options available to us for this DHCP range, such as where to set our DNS server, we can go over to DHCP options, and we can click Add. DHCP ships with a bunch of additional options, each labeled with a numeric value. In here we can search. If we search for DNS, we will see DNS server, which is option 6. And we can set that to whatever value we want. For example, I'm going to set it to the value of our firewall, which is at 192.168.1.1. But if you had something like a Pi-hole or an AdGuard server, you could set it to that as well. We'll set the interfaces we want it to apply to, and we'll hit Save and Apply. And now we can see that we have this DNS server set under this interface. And if we had multiple interfaces, we could configure them to use the same DNS servers or different DNS servers based on that. You can pretty much ignore DHCP boot, unless you're doing something like PXE booting. But if you are, the settings are all available here. Again, this is some of the niceties that comes with DHCP from DNSMasq, is that it is simple out of the box. Everything is in a single interface. And that includes DNS. So let's circle back around to DNS and let's take a look at the general settings. Now, in this case, DNSMasq is already listening on the LAN interface, but we'll note that it is listening on port 53053, which is not the standard DNS port. By default, DNS listens on port 53. Since DNSMasq is listening on 53053, something else must be listening on port 53. And just like before, when I previously covered Unbound DNS, if we go to Unbound General, we will see that Unbound is actually listening on that port 53. So what that means is currently the Unbound service is handling our DNS. Unfortunately, as we see here, there is an option to register DHCP static mappings, and there's an option for register ISC DHCPv4 leases. However, this is for the older version of DHCP. And if we want to get our DHCP devices in DNSMasq to register with DNS with Unbound, meaning that we can look things up internally by their host names, we need to connect DNSMasq and Unbound. And there's a couple of ways to do that. We can put Unbound behind DNSMasq, or we can put DNSMasq behind Unbound. My preference is that we hit DNSMasq first, so that we resolve internal host names before forwarding the queries. Then we let Unbound handle outbound connections so that we can still leverage DNS over TLS. So for a new setup, what that means is we're going to disable Unbound and hit Apply. We're going to go to DNSMasq, we're going to go to General, and we're going to change the port to 53 and hit Apply. This is going to set DNSMasq as the listener when we make a DNS request to the firewall. Then we're going to go to Domains. We're going to click Add, and we're going to create a wildcard, which just means any domain. And we're going to forward the request to 127.0.0.1, which is just this firewall. So that basically says query yourself. but we're going to change this to port 53053. And I like to give this a description of Unbound forwarder. And we'll hit apply. So now when a DNS request comes into the firewall, it will first check with DNSMasq. And if DNSMasq doesn't have the entry, meaning that it's not a DHCP registered device, it will forward the query back to the firewall on port 53053. But you'll notice we don't have anything listening on 53053 anymore. So what we're going to do is we're going to navigate back to Unbound, go to General, check Enable, and change the port to 53053, and hit Apply. Once we have configured port 53053, and we've enabled Unbound DNS to listen on that port, we also need to go over to General and make sure that we check the boxes for Do Not Forward to System-Defined DNS Server for DNSMasq, and Do Not Forward Private Reverse Lookups, and hit Apply. So now, if you want to create local DNS entries, you can do it from the Hosts section. Or if you want to forward whole domains, you can do it from the Domains section. And just set the rules to forward them before our master forward rule here. But we still need to configure Unbound DNS. I'm not going to go through that here because I've already made that earlier video on it. But the only difference between my earlier Unbound DNS configuration guide and today is going to be this port listener should be 53053. And now, if I bring up a command prompt and I do a name server lookup on google.com, I get a response from the firewall, meaning that the forwarder is working. The benefits of this particular setup are that you can resolve any of the leases that you have coming into DNSMasq, but you can still benefit from the block lists and other features of Unbound. So let's do some testing. On my test machine here, I currently have a static IP applied. Let's go ahead and disable that static IP and set it to automatic. Then we can use the ipconfig command to see what address is assigned to me. And we can see that I got .112. As I spoke about earlier, you can see my default gateway and subnet mask both got set here. From Opnsense, we can go to DNSMasq and then to leases, and we will be able to see the IP address that was assigned and the MAC address that it was assigned to, as well as when that lease will expire and the host name of the machine it's connected to. We can also see that it is a dynamic lease, meaning that this IP address could change when it reconnects. But we do have a little plus here. We can add a reservation. That's going to take us back to the DNSMasq settings page under the Hosts tab, where we can now enter the host name of the machine. This is what it would resolve. We could manually override the domain if we wanted to. I'm just going to set it to local. We could change the IP address that gets assigned. I'm going to just set it to 10. Give it a description. Click Save. We'll see that device show up here now. We'll click Apply. Now, you could wait until my device's lease expires, but in this case, I'm just going to do an ipconfig release and ipconfig renew. And you'll see that I now got that .10, which also means if I now do an NS lookup on my machine.local, we can see that it will resolve to the .10 address that we set it to, showing that our DNSMasq reservations are registered in the DNSMasq DNS server. And if we go to leases, we can now see that that lease type has changed from dynamic to static, meaning that that IP address assignment to that MAC address is not going to change. Now in this video, I've opted not to talk about Kea DHCP. Kea is another DHCP option that Opnsense provides. However, many of its features are still locked behind the CLI, meaning that there's not a good way to do it from the web interface, which just makes it a little bit more complicated. It's also a more scalable DHCP server, and a lot of features that probably aren't necessary for the home user. Someday, I may make a video on it if I decide to dive any deeper into the high availability features that it has built in. But I find it really hard to recommend over DNSMasq, which has so many little convenient features like the Opnsense guide on implementing Unbound and automatically registering DHCP leases into the DNS server. As we get towards the end of the video here, I want to talk about a couple of tips and tricks for actually migrating from ISC DHCPv4 over to DNSMasq. Now, before you can begin the migration, you need to decide if you're going to make any changes to your DNS configuration. You can continue to just use Unbound the way that we had it configured in part 1. However, if you do that, we need to go in, and when we enable DNSMasq, we need to make sure that we set the listening port to 53053 and that we do not configure the forwarder in DNSMasq, instead allowing Unbound to continue running as configured. However, if you want to switch both DNS and DHCP over to Unbound, you can follow the steps that we did earlier in this video, timestamp on the screen now, to change the listener on Unbound to 53053 and configure DNSMasq to forward to Unbound. Once you've made the changes to DNS, you can follow along here. We're going to go back to the server from part 1. We're going to migrate our DHCP reservations and DNS hosts. If you currently have ISC enabled, in order to migrate to DNSMasq, you will need to disable ISC v4. And the way that you do that is you just navigate to each of your interfaces that you have it enabled on. Make sure to uncheck the box for enabled. Save your changes. And as long as you no longer see the option to stop or restart the service in the top right corner, ISC should now be disabled. Now, one thing I ran into early on when I was doing this was it kept giving me some problems with the DHCP socket already be occupied on Opnsense. That was because I had missed one of my interfaces. So if you're running multiple interfaces, for example, on this example firewall, I have a LAN and an opt1. Double check that LAN. That one is also disabled. You will need to do that for each of the interfaces before switching to DNSMasq. Now, once you've got that done, you can navigate to DNSMasq, DNS, and DHCP, and click on General, and click Enable. Now, if we want to migrate our DHCP reservations from our old ISC, navigate back to ISC DHCPv4, specifically for the interface that you're looking for the static mappings on, and you scroll down to your static mappings. You'll see an option here to export as CSV. In this case, I've created one sample static mapping. So we can export as CSV and export that file. Then if we go back to services, DNSMasq, and go back to hosts, in the bottom right here, we can click on import as CSV, choose that CSV file we just exported, click the checkbox to import, and you'll see we've imported that static mapping. So this is great if you have a lot of reserved IP addresses that you need to migrate into DNSMasq. If you have any questions or comments on things that we should have covered as part of setting this up, leave them in the comments. I'm always looking for ideas on ways that I can improve and expand on the things that we're going over in these guides. Until next time, thanks for watching.